to everyone. Thank you very much for the invitation. Very nice to meet you. So as Brian said, I'm Esteban. So I'm a neurologist and a PhD candidate at Paris Brain Institute. And I will go over some results of our recent work in a recent collaborative study in which I'm involved. So as a quick introduction, so as well, like many of you, I believe, I'm very interested in dreams and cognitive processes during sleep. And I really want to understand more about how this what is about dreams, what happens during dreams. And until now, the problem is that to study dreams, you only have dream reports, right? So people have all these mental contents during sleep, and when they wake up, they tell us what they remember about their dreams or their mental content during sleep. But usually these dream reports are fuzzy or incomplete, inaccurate because of memory biases, because the encoding, storage, and recall are usually disturbed during sleeping, or at least during the sleep to wake transition. So in a way, sleeping remains, what happens in the mind of a sleeper remains a black box. So one of the objectives of me and my colleagues is to try to open a little bit this black box. And just a quick reminder, but I believe all of you already know all of this. So in humans, sleep is usually defined or classified according to different physiological parameters like brain activity, eye movements, muscle activity. And usually, so to stage sleep, so experts look at 30 seconds windows of these different time series, so brain activity, eye movements, etc. And they classify the state of the brain either in wakefulness or in sleep, sleep being divided in non-REM sleep, which is comprised of N1, N2, and N3 stages, and REM sleep. And as I believe also you know, we usually transition from these states in a cyclic way during the night. We go from wakefulness to non-REM sleep to REM sleep, back of wakefulness in many cycles during the night. But also there are some hybrid states, some borderline states between wakefulness and sleep. And between wakefulness and REM sleep, you have lucid dreaming, which all of you know very well. And as you already know, it's this state, this very exciting state where you know you're dreaming, you're aware that you're dreaming, and so you can control to some extent your dream. And usually your metacognitive and volitional capacities are very close to what you have in wakefulness. And what is great about lucid dreaming in research is that trained lucid dreamers can signal to researchers when they are dreaming. They can, for example, do a code with their eyes to say, hey, I'm dreaming right now. So we can study in real time these dreams. So this is fantastic, but has the limitation that lucid dreams are quite rare, as you know. Like only 5% of people have frequent lucid dreams. Maybe all of you are part of this 5%, I don't know. But in any case, it's quite rare to find very trained and skilled lucid dreamers to study in the lab. Fortunately, there are some medical conditions that make lucid dreams more frequent, like narcolepsy. Narcolepsy is a medical disorder where in fact people suffer from excessive daytime sleepiness and from very rapid REM sleep onset. So they actually sleep a lot during the day. They sleep a lot in REM sleep, and this is maybe one of the reasons why they have so many lucid dreams. So it has been shown that they have in average 8 lucid dreams per month compared to controls that have usually less than 1 lucid dream per month when they are not trained. And since they sleep a lot during the day, it's even easier to study these lucid dreams in these narcoleptic participants. So just to say that this is a population that we are very interested in our lab. So back to lucid dream, as you know, so a lucid dreamer can signal via their eye movements or other codes that he is dreaming. So one-way communication with a lucid dreamer is possible, but what about two-way communication? And that, as I know that I even believe that Karen Concoli is on the crowd, I believe. And if not, you know her and you know her work. So I will go very fast about this. In a nutshell, it has been shown that yes, real-time communication with a lucid dreamer is possible. You can, in some cases, ask questions to a lucid dreamer that he can respond using eye movements or facial muscle contractions, for example. So it's possible. But this is why it's really a paradigm shift, because in this study, so Concolia and colleagues, they showed not only that lucid dreamers can control their dreams and their eye movements and senior lucidity, but also that the channel of information between the environment, between the external world and the mind of the sleeper is open during lucid dream, which is very puzzling since sleep is usually considered as a state of disconnection from the environment. So we ask ourselves the question, is this capacity to integrate information from the environment and to behaviorally respond to this information a feature specific of lucid dreams, lucid dreaming, or is it a feature that can exist outside of lucidity and in other sleep stages than REM sleep? And so to try to answer this question, we began a new study, a new collaborative study with Bashak Torker, Emma Shabani, and which was supervised by Lionel Nakash and Delphine Udiet. And in this study, what we did is that we presented, so it was a lexical discrimination task. We presented words like table or pseudo words like trail to participants. And we explicitly told the participants that they should sleep during the experiment, but that they should still answer to the stimuli while sleeping. And what the participants had to do is to say, okay, this was a word or this was a pseudo word. And for example, if they heard the word table, they had to frown 3 times to say, okay, this was a word. And if they heard a pseudo word like trail or this, I don't know, they had to, for example, to smile 3 times to say, okay, this was a pseudo word. And blocks of stimuli during 1 minute, so on blocks, were alternate with off periods where no stimulation were presented. Okay, and we did this task in 27 patients with narcolepsy, since, as I said, they are usually very skilled lucid dreamers, and we recorded several naps in this population, and so naps were labeled as lucid naps when the participant at wakefulness said, "Okay, I was lucid. I remember being lucid," and other naps were labeled as non-lucid if the participant said, "No, I was not lucid." And we also did this task in 22 healthy subjects with no lucid dreaming experience, and that didn't report any lucid dream. Okay, so the first thing that we wanted to check is if the participants indeed.
Oh, hey, sorry, that was my mistake.
Yes, don't worry.
I wanted to really just quickly check because you're the host. I wanted to quickly reclaim because I think a few people are in the waiting room.
Okay.
Sorry for the
go ahead. Don't worry.
I'm going to admit a few people here.
Go ahead.
I think some good additions. So yeah, and then I'll pass it back over.
Mm-hmm.
Seems like I should be able to make it co-host. But yeah, I will just.
I believe you can.
You can make me host as well, so I can let people in.
Yeah.
I believe you can just like remain host and just allow me to present my slides. I believe there is an option, but I don't know how do you do it, where you allow
it's
people
under security.
Okay, cool. Yeah, let me just bear with me a sec.
Yes, of course.
Okay. Yeah, I think I figured it out. So yeah, if you try to share your screen, I think we're good to go. Pretty easy setting to switch. Yeah, Esteban, are you able to share your screen again?
Yes. Okay.
Perfect. There we go. A little intermission there.
Okay. Okay. So as I said, we wanted to check if the participants responded to the task, right? So here what I present is the response rate. So the number of trials with a response relative to the total number of trials. Here for wakefulness in narcoleptic participants. So in green, you have the response rate during the on periods where there were stimuli presented, so they should respond to the task. And in blue, in the off periods where there were no words or pseudo words, so the participants should not respond. And as you can see, indeed, there is a great difference between these two conditions because participants indeed did the task during wakefulness. Also, if that was not surprising, we also found that the participants did the task in N1 sleep, so in light sleep. So this was not surprising because we know that N1 sleep is a very light level of sleep where you can still kind of respond a little bit. But what was very cool is that we replicated Concoli and Al's result, showing that during lucid REM sleep, participants indeed can respond to the task while sleeping. And what was even more interesting and puzzling is that even in other sleep stages than lucid REM sleep, so in normal non-lucid REM and N2 sleep, and even at some extent in N3, we observed like significant responses, so higher than chance responses to the task in narcolepsy participants, suggesting that participants indeed could respond to the task, even if with less frequently than in wake on a lucid REM sleep, but they still could respond sometimes to the task in this paradigm. This was for narcolepsy participants. We also analyzed the data for healthy participants, and here the results are much are weaker, of course. We don't have the same power in our effects, but still we were very puzzled by the fact that even in healthy participants that didn't report any lucid dream, we still observed higher than chance responses in REM sleep and N2 sleep, not in N3 sleep. So even in healthy participants, there seems to be a capacity, a rare capacity, but still that exists to respond to external stimuli during sleep. So until now, we showed that participants indeed contracted their muscles, facial muscles, in response to stimulation, but we didn't know if they did perform the lexical definition task or not. So we looked at we checked whether they were accurate or not. So here I show the accuracy for healthy participants and narcolepsy participants. So each dot is the accuracy of one participant, and what you can see is that participants are mostly correct in the task. They above chance level of accuracy for N1 and N2 sleep in healthy participants, and for all sleep stages other than N3 for narcoleptic participants. So this suggests that they really did the lexical discrimination task. They really processed at a high cognitive level the stimuli during sleep. Unfortunately, we didn't have enough trials per participant to compute this analysis for REM sleep in healthy participants and for N3 sleep in the narcoleptic ones. So this is a limitation, but still, this is some evidence that participants during sleep can indeed correctly respond to a task like this. So our first concern was the following one. If participants responded in these trials labeled as sleep where the participants responded, maybe they weren't really asleep. Maybe they were awake. Maybe this was a short awakening during sleep, and the trial was mislabeled as sleep, but actually it was a wakefulness trial. This was our first concern. So we wanted to check this eventuality. And so to do this, we computed different neural markers that are known to be able to distinguish sleep and wakefulness, mainly the power in the alpha band and the power in the delta band. As you may know, the power in the alpha band should be much higher in wakefulness than in sleep, and the power in the delta band should be much weaker in wakefulness than in sleep. And indeed, what we showed is that both for the pre-stimulus period and the post-stimulus period, the alpha band activity was significantly higher, much higher in wakefulness compared to every sleep stage in the both group of participants, and the delta activity was much weaker in wakefulness than in sleep. And sorry, here I'm showing only the responsive trials. So this is the marker for only responsive trials. So in responsive trials, the brain activity during sleep was clearly different from wakefulness, suggesting that indeed participants were asleep during these sleep responsive trials. They were not awake. So this is very reassuring. Okay, having said that, so we showed that participants seem to be able to respond to this difficult task during sleep, and that their brain activity seems to show that they are not awake, but they are really asleep. But there must be something in their brain that can account for this responsiveness, right? Because most of the time during sleep, they don't respond, but sometimes they respond. So what happens in their brain that can account or explain this responsiveness, this transient responsiveness? And we made the hypothesis that maybe before the stimulation, the participants were in a higher cognitive state and a more richer cognitive state in the trials where the stimulus will be followed by a response than in non-responsive trials. And to try to measure this, we computed some markers, some brain neural markers that have been used previously to quantify consciousness in brain injured patients. So when you have a brain injury or a brain lesion, you can sometimes be in a vegetative state, which is a state of wakefulness, but without consciousness, or you can be in a minimal conscious state that like you're a little bit conscious, but not really normal, or you can be conscious. And some markers have been shown to be able to discriminate this level of consciousness. It can be, those markers are spectral power markers, like the delta band or alpha band activity, like very usual markers, but also complexity markers or connectivity markers. Complexity markers like Kolmogorov complexity or permutation entropy are markers that, in a nutshell, quantify the amount of information that is encoded in the brain signal. So the more a brain signal is predictable, the less it encodes information, and the less complex it is. And the more the brain signal is unpredictable, like random, the more it encodes information and the more complex it is. And it has been shown that complexity is very closely related to consciousness or higher cognitive function. And connectivity also seems very important for cognitive function. And connectivity is the amount of information that is shared between brain regions. So we quantified these different markers in our data, and we did that for both groups of participants, narcoleptic participants and healthy participants. And what I show here is the subtraction of the mean value of these markers in responsive trials minus non-responsive trials for all of these markers. So you have in yellow spectral markers, so power in delta band, theta band, alpha band, beta band, gamma band. So very slow oscillations, very fast oscillations. You have a connectivity marker, the WSMI, weight and symbolic multi-information. And you have three complexity markers. K for Kolmogorov complexity, PE for permutation entropy, and SE for sample entropy. And what you can see is that when a bar goes to the right is because the value of these markers are higher in responsive trials than in non-responsive ones. And when the bars go to the left is because the values are higher in non-responsive trials than in responsive ones. And what you can see is that you have the same pattern in healthy participants and narcoleptic participants, where responsive trials seems to be associated with less power in the delta band, so less slow oscillations, and with faster oscillation and higher complexity. And this seems to be the case for the both group of participants. And what is interesting is that this pattern is very the same one that we can obtain when you contrast conscious states, like conscious or minimum conscious states, to vegetative states. So all of these markers seem to go in the sense of higher cognitive state in responsive trials compared to non-responsive ones in both group of participants. Okay, so we ask ourselves, okay, so these markers seem to be different in responsive trials compared to non-responsive ones. Is it possible to predict at a trial level if a trial will be followed by a response or not? Can I, if I look at the EEG activity before the stimulus, predict if the trial will be followed by a response or not? So to do that, we trained a machine learning classifier with these neural markers independently for the different sleep stages in narcoleptic participants and in healthy participants. And more precisely, what we did is we first trained a machine learning algorithm in the narcoleptic participants with narcoleptic participants data. We, of course, follow what is called the cross-validation. So to be sure that we didn't overfit the classifier. So we trained with a part of our data and we trained in the remaining data. And we did this in narcoleptic participants. And then we looked if our classifier could generalize to healthy participants data. And what we obtained was two very interesting results. The first one is that we could indeed, when we trained our classifier with all responses or with only correct responses, distinguish much better than chance if a trial will be followed by a response or not. You can see here in N1, in N2, and REM. So for example, in REM sleep, non-lucid REM sleep, again, you have with only correct responses, more than 70% of accuracy compared to 50% of chance. So we can really predict better than chance with these markers if there will be a response or not. But very interesting, when we train the classifier with only incorrect, sorry for the typo, with only incorrect trials, the classifier becomes much less accurate. And for N2 or REM sleep, you cannot decode anymore if there will be a response or not. So this suggests that there really is information in these markers that distinguish responsive from non-responsive trials, that can track responsiveness during sleep, and that these markers really index higher cognitive states and not just motor processes. Because when you train with incorrect trials, you cannot discriminate anymore this responsiveness. So this means that it's really a high cognitive process that is indexed by these markers and not just motor stuff. And the second very interesting result is when we train with the narcolepsy participants data and you try to classify in healthy participants data, you can still do it much better than chance, which suggests that the same brain dynamics underpin responsiveness in both narcolepsy participants and in healthy participants. All of this, again, for non-lucid trials, non-lucid naps. So there seems to be a capacity for behavioral responsiveness, for integration of external information and responsiveness, even in the absence of lucidity during sleep in both populations. But next, we wonder, okay, what about lucid sleep? Okay, what is special about lucid dreaming? First, as I showed you, responses are more frequent during lucid REM sleep. So we still have responses in the absence of lucidity, but responses are more frequent during lucid REM sleep. So this is the first difference. But the second and much more interesting difference is that lucidity seems to be associated with recall of having done the task. What I mean is when you take all responsive trials and you see if they were lucid or not, when the participants were lucid, they recall having performed the task in 75% of the cases, and they didn't recall having performed the task in 25%. That means that when the participant wake up, we ask them, okay, did you do the task during sleep? And lucid participants said, yes, I remember, I did the discrimination task during sleep. 20% of them didn't remember. But when you ask the same question to non-lucid participants, even if they did perform the task, we know that they did perform the task because we only taken the responsive trials. When you ask to non-lucid participants, most of them don't recall having done the task. So they did the task, but they don't remember having done the task. So this raises a very interesting question. Actually, two questions. If the non-lucid participants did the task, but they don't remember having done it, were they conscious of the stimuli when they responded, or was this an automatic process? And the second question, which is the mirror of the first one, is, okay, if we presume that actually the non-lucid, the participants that responded were conscious when they responded, why they don't recall having done so, and why lucid participants do remember? And this is a very interesting point of discussion. I will talk about this at the end. But just this was the first difference that we found between lucid dreaming and normal sleep. The second one concerns the neural markers. So as I told to you, in non-lucid sleep, these neural markers of the complexity markers or the spectral markers could distinguish responsive versus non-responsive trials. For example, in non-lucid REM, you see that this marker of complexity was higher in responsive trials than in non-responsive ones. It's the same for the other markers. They can distinguish responsive from non-responsive. But what you can see is that in lucid REM, these markers don't change actually with responsiveness. They are not modulated by responsiveness. And they actually always at a very high level. Like, for example, when you compare responsive trials and non-lucid REM, they are the same level that both non-responsive and responsive trials during lucid REM sleep, which could suggest, so there are many interpretations, but one of them is that actually lucid dreaming is characterized by a more rich, but also more stable state. Like maybe during non-lucid sleep, participants oscillate between higher states and lesser state, if you want, but lucid participants are always in a higher state. And the last result, I won't go into details only if you want. I can explain it, but it's a little bit complex. But we could show that during lucid REM sleep, there are neural markers of conscious access, conscious processing of stimuli during responsive trials. This means that when the participants don't respond to the stimuli, maybe they are conscious in their sleep, but they didn't access the stimuli, the word, so the word in a conscious manner, but they did when they responded to the task. I because of time constraints, I won't detail this very much, but we can discuss it afterwards if you want. But in a nutshell, in this study, we showed that, okay, behavioral responsiveness to external stimuli seems to exist in every sleep stage, even if its frequency decreases with sleep depth. That windows of behavioral responsiveness are associated with markers of higher cortical processing. And all of this suggests the existence of transient windows of cognitive integration of the external world during sleep. And in addition, we showed new evidence in favor of the existence of of conscious processing of external information during lucid sleep. The points of discussion that remain like an open question is, as I said before, are non-lucid participants conscious during responsive trials? One possibility is they are not conscious, they respond in an automatic way, and that is why they don't remember having done the task. However, we personally don't think that. We think they were conscious, but they forgot that they were conscious that they did the task. Like in the same way that you can forget your dreams, you can dream something afterwards, you forget about your dreams. Maybe they were conscious, they responded consciously to the stimulation, but afterwards they forgot about the response. Which raises an even more interesting question, which is maybe lucid dreaming is just a more metastable brain state or cognitive richness. Like maybe we all, to summarize and to simplify it, maybe we all are lucid at some times during the night, but we forget about this because these states are very transient and not very sustained in time, so they don't allow for encoding in memory. And maybe the only difference between lucid dreamers and normal dreamers is the fact that lucid dreamers can remain in a more sustained manner in this rich state, in this rich cognitive state, which means the first thing that the first consequence of this work is that if we by tracking this fine-grained neural fluctuation during sleep, we could allow to detect these windows of reactivity in real time, allowing for two-way communication during sleep in any sleep stage. But it also means, and that maybe is more interesting for you, that if we enhance these periods of cognitive richness, we could potentially allow for increasing lucid dreaming frequency. If we suppose that all of these moments of responsiveness are in fact potential lucid dreaming moments, but they are so short that we don't remember them as being lucid, if we can enhance these moments in a way, maybe we can increase the degree or the extent of lucidity during dreams. Okay, that's it. I went fast because that way we have time for discussion.
Yeah, that's great. Yeah, really good talk. Definitely covered a lot of ground in a short period of time. And
yes, maybe I want to. I tend to talk very fast, and go very fast. If some points are not clear, I'm happy to go over them again. So.
Yeah. No, I think it was all clear, and we can backtrack to some of the slides and content, in this question and answer session, which would be the next call it like 20-25 minutes, but we'll see where the discussion goes.
Yes, of course.
And yeah, if you have a question, probably best to raise your hand or drop it in the chat, and we can just bounce around the group here. So I see a couple of hands raised. I will pass it over to Ryan for a question.
All right, so buenas tardes or bonsoir, I'm not sure which to use, but good afternoon, good evening to you. Thank you so much for presenting to us today. And as terms of talking fast, I do the same thing. People have trouble understanding me, so you are right at home here. One thing I picked up on when you were going through, I'm blind, so I couldn't see the visuals, but I'm pretty sure I caught on with what you were saying pretty well. You were discussing those markers that you were taking, the PE, the SE, the different markers that you were using to determine that were associative with higher cognitive states. Now, one thing that caught my attention is in terms of stimulus response, you have people more likely, have a clear association there, it seems, from, responding to, those trials, responding to that stimulus while asleep and that particular cognitive markers. Do you think that such markers could be used potentially in the future as a way to determine whether or not you should signal someone if you're trying to, for example, induce lucidity?
Yes, so if I understood correctly, your question is, can we use these markers to, like in real time, to detect when you send a signal to someone to say to them, like, you may be lucid now, or you are dreaming, so something like that? That's what you meant?
Yes, basically, yes. That's what I meant.
Yes, I believe, yes, I believe that these neural markers that seem associated with responsiveness, when they're like computed before the response and before the stimulus, I believe they could be leveraged to track in real time neural fluctuations and to be able to tell when someone is in a higher cognitive state, which may become a lucid, maybe it already is, or maybe it could become a lucid dream, a lucid moment. And maybe by sending some signals at this particular moment, when these markers are at their highest, you could indeed induce lucidity in participants. I do believe that. I don't know if that was your question, if I got it correctly.
Does that cover?
Just had to toggle down to my mute button on my phone. But yes, you did. Thank you very much. That's kind of the thought process that I had when I was listening to that. So I'm glad to hear that you were thinking the same way.
Yes. Thank you very much.
And I think a lot of people in this group we're probably thinking that too, and thinking like, can I get this at-home device in a kind of a user-friendly form factor piece of hardware to try to get to that, like cognitive richness or complexity, which hopefully we can get there in the not too distant future. I see a few more hands up. I'll go to Karen Conkley, who I think is calling in from the Swift 210 room over there. So I'll pass it up to her.
Hi, can you hear us?
Yep, we can hear you.
Okay, cool. I think we have two questions, but my question was just, I'm curious why you chose the 1 second before Q presentation.
Mm-hmm. Okay, that was, there were two reasons. The first one is, so 1 second before presentation is, we wanted to be close enough to the stimulation to be sure that we were in the exact brain state when the participant processed the stimuli, right? Because if we took, for example, 5 seconds or a more prolonged time period, it could be like far away from the stimulus and from the moment when the participant processed the stimulus, and maybe it would be less accurate to predict the subsequent response or not. So we wanted to be close enough from the stimulus to be in the exact brain state where the participant was when he integrated or not the stimulus, but also we needed a period long enough to compute some of the markers. So for example, for some of the markers, for example, delta power, we are really in the, it's very like limit, like normally 2 seconds or 3 seconds would have been better to compute, like for example, power in the delta frequency, but it would have been too far away from the stimulus. So 1 second seemed to best compromise between proximity to the stimulus and having enough time to compute enough time. Yes, a long enough time period to compute some of the markers, like for example, the WSMI in the theta frequency or the spectral power in the delta frequency, for example.
Thank you.
I also had a question. I don't know if it's okay to ask, but this is Karen, and thank you so much for your presentation. We've been like fangirling over it for like months and months. So thanks for presenting. And I just wanted to know if you were willing to share like any of the revisions that you're working on, like what did they ask you to do?
Yes, I can tell you in a nutshell. So actually, if some of the results I present, well, not very much, but some of the results I presented were actually suggestions of the reviewers. So, for example, when in the classifier we use correct, incorrect, or all responses, that was a suggestion from a reviewer. So we initially, in the initial version of the paper, if you read it in the archive, we only used like all responses, and by like using only correct, only incorrect, we had this very nice result. That was a suggestion of a reviewer. They also asked us to do more stimulus-centered analysis, like for example, ERPs or time frequency, which we added to the new version of the paper. So these analyses are not in the bioRxiv version, but we will probably update the bioRxiv version very shortly before, we hope, the the response of natural neuroscience. But so yes, we did some post-stimulus analysis like ERPs or time frequency analysis that in a very nutshell, they suggest that there are local brain activations, mostly in the frontal regions, when participants respond. So what we show is that there seems to be a very transient activation, increase in fast activities in the frontal electrodes when the participants respond to the stimuli compared to the moments when they don't respond. And this activation, this increase in high frequency activation happens in the same time window where we can observe motor preparation potentials in response locked ERPs. So we interpret this, maybe we're wrong, but interpret this like local brain activations in frontal and motor circuits that allow for the response in responsive trials. That's for one of the things that we added in the new version that is under review.
Awesome. Yeah, almost 75% of predicting when they're going to respond is like incredible. So thank you.
Thank you very much. Yes.
Yeah, good questions, and follow-up questions are also welcomed here. I think we'll have some time. I'm seeing a few other raised hands here. It looks like well, I was going to go to Jay, but it looked like you lowered your hands. Are you good, Jay?
Yeah, I'll leave it for later if there's time. No worries.
All right,
It's a little
cool.
off topic, but I want people to ask about the topic at hand.
All good. And so we'll go to I see Dr. Ken has his hand up, and so let's go to him, and then we'll go to Bill Meyer after that.
Yeah. So yeah, interesting stuff. Wow. I guess I had a few thoughts. One is, is there any way to make an association with like PGO waves and the phasic eye movements? Is that relate to maybe this heightened arousal that could improve performance and on the task?
Okay, your question is like, if I understand correctly, because yeah, we know that, for example, in REM sleep, there are different patterns of different types of REM sleep with tonic activity, or in the different type of eye movements in REM sleep, so with different, which are like phasic or tonic REM sleep, and if this can have an effect on responsiveness. Is that your question?
Yeah, like you would think, the dream generator in principle is coming from the brainstem and sending the PGO waves that go from the pontine to the thalamus, then to the visual cortex. So maybe the phasic part might be, a heightened window of maybe gamma or responsiveness to the task.
Yes, we thought exactly the same thing. We tried to look at eye movements to see if it was true, and we found no difference between tonic and phasic. So there was no evidence for a difference in responsiveness according to the pattern of eye movements of the tonic or phasic. But we actually thought about that initially, so we were disappointed when we didn't find the result in that sense.
I mean, the eye movements could be a result of both, the PGO waves and some kind of orienting response, but also scanning the visual world in the dream. So you would need to, in a way, disambiguate those two sources of eye movements. I'm not sure how to do that, but it's to consider. And then I guess one other thought I had is, you would think, I guess a simple thing would be that playing any stimuli during the dream or during REM sleep, you think would maybe bump up brain activation because there is a kind of alerting or like, so did you see anything like that?
So what we did so on control analysis, we looked if for sure, I believe you're right. If playing stimuli during sleep could clearly increase alertness, and maybe participants are in like not as asleep as they should be in normal sleep. That is totally possible. What we try to look is if the main values of these markers, complexity, spectra, and all of that in on periods was higher or not compared to off periods. So in off periods, there were no stimuli, and we compared the mean value of these markers in every sleep stage in off periods compared to on periods, and we didn't find any difference. So
Wow.
That's reassuring in the sense that, in principle, at least on average, because we cannot like in average, the values of these markers are not different when we present stimuli and when we don't present stimuli. But of course, that's on average. Maybe there are small modifications due to stimulation. That's clearly possible. Yes.
Wow.
Yes, and also another important thing is that we present a stimulus every 10 seconds, right? So we have like you have a stimulus, word, pseudo word, and then we wait for 10 seconds before the next stimulus. And that's why also we computed the markers just in the second before the next stimulus. So that means that there have been like 9 seconds relative to the previous stimuli. So normally, of course, you can have a global like progressive awakening due to stimuli, but in any case, you are at a distance from the previous stimuli, so maybe not as excited as just afterwards the stimuli. Yeah. I don't know if that's clear. Like since we computed this.
I guess I'm curious, like so the healthy. Well, I thought it was fascinating, with using the narcoleptics, and I have a friend who has narcolepsy, has a very active dream life. But with the healthy subjects, did they report hearing the stimuli in the dream, like a dream incorporation?
No. None of them reported nor lucidity nor having performed the test during dream. But initially we were like, okay, that's weird. But then when we saw that actually non-lucid narcolepsy participants also reported not having done the test during their sleep, we were reassured, because we thought, okay, actually we find the same pattern in non-lucid narcolepsy participants and in healthy participants. So it's like, okay, the big difference that we see are not in terms of brain activity or in terms of brain activity and phenomenal in report, subjective report. The big difference that we see is more between lucid narcoleptic and like non-lucid, like both narcoleptic and healthy participants. But healthy participants and non-lucid narcoleptic seems to have the same profile, like absence of subjective report of having done the task at awakening, and modification of brain markers by responsiveness. In contrast with lucid participants, we had no modification of brain markers with responsiveness, and that indeed did report having done the task.
Wow. Okay, very good. Thank you.
And good questions. And I see a couple hands up still. We'll go to Bill Meyer next. Are you there, Bill?
Yeah, I am. Esteban, great presentation, really smart research. I'm very happy to see this kind of stuff being done. So you actually answered the question I was going to ask, which Raj asked about tonic versus phasic. So that's interesting that you did not see a difference. But was there any implicit payoff for the subjects that responded? Meaning, like, and I have to look at your protocol more carefully. But did for instance if somebody answered correctly, did you not continue to ask? And did you make any correlations between, how many times you asked before you got a response?
So no, normally there was not implicit thing, because all participants had exactly the same protocol, where a word up to the word was presented every 10 seconds. Like we have 1 minute blocks where every 10 seconds you have a word up to the word, then you have 1 minute pause, then you have again a block with a stimulus every 10 seconds. So even if the subjects don't respond, the stimuli remain the same. So you don't have any change in protocol according to the response or absence of response.
Okay, that's good. I'd be curious. I mean, that makes the data seem much more solid. Obviously, I'm also curious what would happen if that was switched around a little bit. I guess the good research. I really don't have other questions. It's maybe let me ask you one other question. What would be the next step that you would want to, like a follow-up study? What would be the things you'd want to dig into?
Okay, follow-up study, many things. So the first one is that, for example, if you look, for example, at our markers, the spectral markers and the complexity markers really discriminate responsive, non-responsive trials, but our connectivity marker doesn't at all. It's very bad. But this is very probably is probable because we only have 10 electrodes. So we have a very low density montage with 10 electrodes, which is clearly not enough to compute this kind of connectivity measures. And in a very fundamental way, I'm very interested at what happens in brain communication between brain regions during lucid dream or during these responsive moments. Like my guess is that normally you should have an increase of connectivity between frontal areas and parietal areas. And I would like to, first of all, to do the same the same kind of experiment, but with more electrodes, like with 64 or 128 montage, to really have a better view what happens in the brain, like in terms of connectivity or things like that. First thing. Second thing, I really would like to do this in real time. So, okay, can we, like in real time, measure these markers and predict in real time if the participant will be able to respond or not, and send the stimuli in the right windows and see if really we increase responsiveness during sleep. Not because, like, the idea is that maybe the idea is that since we send the stimuli in a random, not in a random manner, but in a fixed manner, independent of brain activity, we cannot predict if the subject is open or not to this information. But if we send stimuli only when we can predict that normally he will respond, we can really see if there is a causal link between these brain states and responsiveness. So I would really like to try to measure these markers in real time and try to predict if the subject will respond or not, and send stimuli in periods where we can predict that he will respond, also in windows where we can predict that he won't respond, and compare the results between these periods where we can predict that there will be responses and the other periods, and see if there is a causal relation between these markers or these neural dynamics and responsiveness. That would be a second point I would like to study. The third point is the question: are participants during responsive trials lucid? Like my subjective intuition, my intuition is that these participants, when they declare not being lucid at awakening, during these short periods of time where they can integrate the information and respond, they actually have all the brain markers of lucid dreaming, but this state is so short that they don't encode it in memory, they don't remember at awakening. So I would like to try to probe these moments of responsiveness to see if they are lucid or not. I don't know, like maybe, for example, you can, for example, try to predict these moments using the real-time computation of these markers. You ask a first order question, like, okay, you send a stimuli, so you say, okay, it's a word, a pseudo word. And afterwards, you ask a second question, a metacognitive question. Is this stimuli coming from the outside or from your dream, for example? And with the hypothesis that a lucid dreamer should be able to say, okay, no, it's coming from the external world. I know that I am doing this task. And the non-lucid one, but at least a conscious but not lucid one, should answer, but it comes from my dream, or not answer at all, not answer at all. Like, try to see if participants know the source of the stimuli when they are not lucid, to try to test this hypothesis that actually they are in a moment of micro lucidity, if you want, but that is too short to become a real lucid dream, you see. For example, these are some ideas that I would like to test. There are other things.
I would love to see you do that research. One thing I can offer just anecdotally from my own experimentation with these things, that it is possible in a longer lucid dream to lose lucidity and then become lucid again when you're playing around with triggering. So I've just personally experienced this. So I say that because I would agree that probably there was a window of time when the person responded, they were probably lucid, and then they weren't. That would be my guess.
Yes, I agree completely. Yes.
Great work. Thank you.
With pleasure. Yeah. Thank you very much. Thank you very much.
Good questions. And I think a lot of people are looking forward to some of those future studies. I'm especially excited about just stimulate people within those receptive windows and see if there's a causal link. I think that's super cool things to explore. I see a few more hands raised. Are we able to go a few minutes over, Esteban? We can try to
yes, of course.
Whatever hands are still raised. I see one name that a bit, I don't know the Greek alphabet, but there's our friend with the Greek letters, and then I see Karen has her hand up again. So how about we go to those two? and then I think we can close it out from there. And I see Bill and Dr. Ken still have their hands up, but I'm assuming that was from before. All right.
Hey, can you hear me?
Yep.
Yes.
All right. Sorry, I didn't translate it to English. My name is Alexei. I'm a lucid dreaming enthusiast from Russia. Thank you for your brilliant talk. I have two questions. The first one is, I'm not sure if I got it right, but is it true that in lucid state, the accuracy of questions was not higher than in just REM state?
Yes, that's right. That's right. Accuracy. We actually compared these states, so there was no significant difference. It seems to be less, but actually there is no statistical difference between lucid REM and the normal REM. So there is no difference between lucid and accuracy in lucid REM, normal REM, or even N2 when you test it statistically. So basically, what we can say is there is no observed difference in accuracy between these states. So this means that actually lucid. The interpretation is that lucid dreamers respond more frequently to stimuli, but actually they are not more accurate. They are at the same level of accuracy that normal non-lucid sleepers.
It actually doesn't make sense because you would, I would expect that the lucid dreamer is like more conscious and like would be more accurate in answering questions. Does that make sense to you?
It makes sense, but only if you, again, we go back to the discussion of before. My hypothesis would be that actually in the moments where the participants, the so-called non-lucid participants respond, my hypothesis that they are actually lucid. My hypothesis that is the same brain phenomenon, but is so short-lived that they actually don't encode this on memory. So when they wake up, they say, no, I was not lucid. But actually, in this micro moment of responsiveness, they were lucid. They just don't remember. And actually, going with one of the persons who asked the questions, he said that in his experience, he has become lucid and then lost lucidity, and so it's possible to fluctuate in this state of lucidity or not. But also, what we observed, I didn't go into the details in the presentation, but we labeled lucid and naps to being lucid or no lucid according to subjective reports, but also we had like a mixed code. We asked the participants, if you are lucid, you will do a mixed contraction. You will contract both your corrugator and your zygomatic. So you will both frown and smile. And we had mixed contractions that match very well the subjective report of lucidity. So in addition, the responses, sometimes participants did these mixed contractions that was the symbol, the code for lucidity that match very well the subjective reported awakening. But still, we observe sometimes where the participants reported not being lucid, but they still did this mixed contraction thing. So we think that they were lucid, they signal lucidity, but they forgot being lucidity. And actually, there have been reports in the literature of lucid amnesia, people being lucid and forgetting about it with the classic oculomotor code. So again, my hypothesis is that all of these responsive participants were in the same brain state that lucid participants, just in a very short time. So that's why they declared not being lucid at awakening, which would explain that accuracy should be the same in every stage.
Okay, thank you. And my second question was, if we can, so if a lucid dreamer or just dreamer can communicate with signs from ocular muscles and all other muscles, maybe can we record the muscle activity the way to enable actually the dreamer to speak and then to decode his speech based on the muscle patterns? Is that possible, do you think?
Wow, I don't know. That would be great. I don't know. I have no idea. I don't know if the muscular decoding, like the decoding of the muscular activity, will contain enough information to like translate into speech. That would be great, but I don't know if it's possible. But I don't have an opinion because I don't know enough about about like the possibilities I don't know. I take a rain check. That would be very interesting, but I don't know if it's possible. My guess is it will be in the future, theoretically. Of course, I speak in the far future. It would be easier to decode the answers from the brain activity than from muscular activity, right? You could imagine. Actually, there are some researchers trying to. They use like deep neural networks to extract like word information from brain activity. So they try to by analyzing with neural networks the brain activity, they try to know in which word the participant is thinking. So I don't know very much about this research. It's not my research, but you can imagine that in the future you could maybe during sleep extract words from brain activity. But again, far future, not today.
Thank you. Okay.
You're welcome.
Cool.
Good, yeah, good questions, Alexei. And yeah, perhaps there's Morse code via facial movements sometime in the future to communicate. Who knows? So
if you yes, again, yes. If you think about like a Morse code, like a code, like you've thought about it in advance, why not? Why not? Maybe, yeah.
And
that would be cool.
Yeah, let's kind of taper it down here with one more question. With yeah, let's hand it back over to Karen in the Polar Lab. I see the hands up there, so I'll pass it back to them for the final question here.
Thank you. I just was curious, like, how many of your participants did the mixed contraction but forgot? Like, how many times did that happen? And also, like, did it ever happen with a non-narcoleptic? Just because I feel like if you told everybody that they could do that, and then sometimes they responded but didn't do that, then like, I don't see why you need to equate responsiveness with lucidity. Like it could be a brain state that enables them to respond, but like lucidity means you're aware that it's a dream. And so you could be aware of responding, but not be aware that it's a dream.
I totally agree with you. There are two hypotheses, right? And actually, we are not. We don't share the same interpretation with my colleagues. So we are two. So we are three main first authors. We are two to think that these responsive windows actually have the same brain dynamics than lucid moments, and it should be the same thing. It's more the problem of stability, like I said before. And the third one, Emma, that you know, because thinks that they are different things. And I totally agree with you. It could be two different phenomena, right? Like one brain state that allows for responsiveness, and like a supplementary necessary condition, a supplementary condition that allows for this metacognitive insight that allows you to know that you are dreaming. I totally agree. It could be two different things, and that's why like a second experiment would be interesting to probe this, like to see if in these responsive moments when you ask a second order question, if the participant know that he's dreaming or not. That would be very. In terms of your first question, I could answer to you. I have to check. I don't know. I cannot answer to you like. Right now, how many mixed contraction we had with with no subjective report afterwards? Not very much, that's for sure. But I cannot tell you how many exactly. But I can check if you want, and I can email you the answer if you want, with pleasure. I can tell you that no healthy participant had mixed contractions. That's for sure, and I agree that will go in the direction of your interpretation. But I believe the only way to know about for sure if these responsive moments are equivalent with lucid moments or not is by doing a new experiment where we probe this explicitly.
Super interesting.
Thank you very much. All right, awesome. And yeah, thanks for all the question all the questions in the question and answer session. And yeah, I think let's leave it at that for now in the interest of time. And I really want to thank you again, Esteban, for joining. That was a really great event and presentation, and just really helpful to get your kind of color commentary. I'm very glad to have been here. It was great. Thank you very much for the opportunity, and very nice to meet you all. And I'm happy to see there are so many people interested about lucid dreaming. And stuff like that. Yeah, and it's very encouraging. And thank you for the
And thank you for the great questions and commentaries. It's really an honor. Thank you very much.
And it's a great mix of academic researchers and more of the kind of tinkerers, you know, that are not necessarily in the academic space, which I think is a great part of this group. We can kind of, you know, combine the two of those and get them connected more and more, because then there's instant research that we can pull into some of these projects as far as, you know, maybe there's signals that we can build into an at-home device, these kind of neural correlates that we can figure out, okay, what are the receptive time windows to apply some kind of stimulus, whether it be light, sound, electrical stimulation, who knows what kind, there's all different types of stimulation modalities, but you know, this kind of research can move the field forward, obviously. And then I'm you know, excited about the potential of this group to have people actually start to tinker with projects to see, you know, does this work, does that work, and really experiment with the, you know, kind of the degrees of freedom and parameter space that we have here. So long way of saying thanks again for people joining, both from the academic perspective and from the more of the you know, kind of hobbyist tinkerer perspective. I think that's the, you know, some of the power of this group. So yeah, let's leave it there for now. Any final parting words, Esteban?
No, just thank you very much again. And if I will be very interested in participating to something like that, like translating this kind of stuff to home devices or things like that. That would be very, very interesting. I believe there is a long way to do that. We still have to show that we really can apply these methods in real time to predict responsiveness or lucidity or whatever. So we are not that yet. We are not there yet, but it would be clearly a very exciting venue for the future to try to develop things like that.
For sure, it's a new frontier. So maybe we can, Dr. Ken, can you play us out with the ukulele?
Yeah, exactly.
So this is our exit music. Thanks again, everybody, for joining. And this will definitely not be the last event for Tech for Dreaming. We're around for the long haul and look forward to you know, connecting with you in the future. So thanks again, everybody, and have a good day. Have a good evening. Bye-bye.
Thank you. Bye bye.
Thank you so much, everybody.
Thank you. Bye.
Thank you so much.
Thank you, bye.